So let's talk about something that is fundamentally changing how our mobile networks are built. It's called ORAN, or Open Radio Access Network. And trust me, this isn't just some minor upgrade. We're talking about a complete teardown and rebuild of the very infrastructure that connects all of us. But that begs the question, right? Why? Why go through all the trouble of rebuilding a system that, for the most part, seems to be working just fine? Well, that's the big question we're digging into. To really get where we're going, you first have to understand the problems with where we've been. Okay, let's get into it. You see, for years and years, the radio access network, all the cell towers and gear that connect your phone to the internet, it's all been built in this one very specific, very closed-off way. And it turns out that old way created some pretty serious roadblocks. And this slide right here, it just perfectly captures that shift. On the left, that's the old world. A network operator had to buy this massive all-in-one black box from a single company. Everything worked together, sure, but it was completely locked down. The ORAN vision on the right is the total opposite. It's about cracking that box wide open and turning the network into a set of Lego blocks where you can pick and choose the best pieces from dozens of different companies. And believe me, that black box model caused some major headaches. The biggest one? Vendor lock-in. Once you bought from vendor X, you were stuck with them for pretty much everything. And you can guess what that leads to, right? Innovation grinds to a halt, the networks become super inflexible, and with only a couple of huge players in the game, the costs just go through the roof. And that brings us to the solution, ORAN. It's this huge industry-wide movement to bring openness, flexibility, and a whole lot of intelligence to the network. It's all about finally breaking open that black box. Okay, so take a look at this. This shows you exactly what we mean by disaggregation. A traditional cell tower base station over on the left is just one single piece of hardware. ORAN comes along and splits it into three distinct parts. The radio unit, or RU, which is closest to the actual antenna, the distributed unit, or DU, and the central unit, or CU. The cool part is that the DU and CU are basically just software that can run on regular servers, even in the cloud. We've gone from one big box to three distinct Lego blocks. But just breaking things apart is only half the battle. You need something to make all those different pieces work together. And not just work, but work smarter than ever before. That's where this new thing called the RIC comes in, the RAN Intelligent Controller. You should just think of it as the brains of the entire operation. It's a software platform that uses AI and machine learning to constantly optimize this new mix-and-match network. And this brain is pretty slick. It actually works at two different speeds. First, you have the non-real-time RIC. It's looking at the big picture, thinking on a timescale of more than a second. It handles long-term planning and trains the AI models. Then you've got the near real-time RIC. This one is way faster, making decisions in milliseconds. It's constantly making these tiny dynamic adjustments to the live network. It's this powerful one-two punch of long-term strategy and immediate tactical control. So ORAN sounds perfect, right? It's open, it encourages competition, it's super intelligent, it solves all the problems of the old system. But, and this is the big twist in the story, in solving one set of problems, ORAN creates an entirely new and, frankly, a much more complex set of challenges. And that's the price of openness. And this right here is the central tension of the whole ORAN revolution. Every single benefit of this new model, the open interfaces, having multiple vendors, software running everything, well, every single one of those also creates a new weak spot, a new vulnerability. It all really boils down to three huge research challenges. First up, interoperability. I mean, if you're buying network parts from 10 different companies, how do you make absolutely sure they're all going to play nicely together? Second, security. A closed box from one company is, well, it's relatively easy to lock down. An open system with a dozen vendors and interfaces everywhere, that's a whole different ballgame. And third, intelligent control. How do you actually build an AI that's smart enough and, more importantly, reliable enough to run our most critical communications? Let's just double-click on that security challenge for a minute. The source material puts it perfectly. It says the very nature of ORAN effectively extends the attack surface for malicious users. In other words, every new connection, every new piece of software is another potential door for a bad guy to walk through. And what's really fascinating here is we're not just talking about the same old threats. ORAN literally creates new kinds of risks. Think about it. Attackers could try to poison the AI models by feeding them garbage data. They could find a tiny vulnerability in one of the open interfaces between two components. Or they could attack the cloud servers where all this critical network software is now running. It's a brand new world of security risks. And that brings us right back to that fundamental challenge of making it all work together, our Lego problem. Look, it's one thing to say, hey, you can mix and match parts from anyone you want. It is a completely different and way harder thing to guarantee that Company A's radio is going to work perfectly and securely with Company B's software and Company C's controller. It is just a massive, massive engineering puzzle. But here's the good news. These huge challenges haven't stopped anything. In fact, it's the opposite. They've kicked off this incredible, coordinated global effort to solve these exact problems. We're not talking about a few companies tinkering in a lab. This is a worldwide quest. And the scale of this thing is just mind-boggling. The O-RAN Alliance, which is the group steering this whole revolution, has more than 300 members now. That includes the world's biggest network operators, all the major vendors, top-tier research labs. I mean, the entire industry is all in on making this work. And this isn't some chaotic free-for-all either. It is highly organized. The Alliance has all these different working groups, and each one is assigned to tackle a specific piece of the puzzle. You've got groups figuring out the overall architecture, groups working on the intelligent controllers, groups defining the open interfaces, and crucially, there's a whole group, WG11, that is 100% focused on security. So basically, the O-RAN Alliance is writing the universal instruction manual for our network Legos. They're creating the super detailed standards and blueprints that will let any company, anywhere, build a block that is guaranteed to fit, to connect, and to operate securely with any other block. And that brings us to the final, critical point. The stakes here could not be higher. All these future technologies we hear about, real 6G, the actual metaverse, they all need a network that's way more flexible, intelligent, and open than what we have today. In other words, they need O-RAN to work. So the big question is, can this massive global project solve these really deep challenges of security and interoperability in time? The race is definitely on. Thanks for joining me.